My name is Steve Devore. I'm a product architect at Leonardo DRS, where for the past 12 years, I've been working designing signal intelligence radios. Over the past 12 years, I've also had the opportunity to be involved in VITA, sharing VITA 67 and 66.5, Biomate coax and optics. And recently, I've had the privilege to serve as the chairman for the VSO as a whole, and most recently, the VITA 100 working group. And it's within that capacity that I'm speaking to you all today. As I was preparing this presentation to talk about what VITA 100 is and this new era that we're beginning, my 4-year-old son was insistent that I needed to talk about Thomas the Train instead. So I've done my best to incorporate that a little bit. So a bit of the idea here is I'm hoping to simplify and stay at a top level. So with that in mind, 3 things. Why VITA 100 is needed now. Next thing is how VITA 100 is building on the legacy of VPX. And then lastly, what 100 is going to be. How's it going to standardize? So first one, why VITA 100 is needed now. There's some easy ways to talk about it. We need additional processing. We need additional data bandwidths. We need more power. But I've tried to look at it in the spirit of ETT a couple different ways. Look at some technology trends and also looked at some historical patterns. So VITA 100, we set 2 objectives, and I broke it up into 2 parts here, part A and a part B. This part A has a continuation of VPX, but a leapfrog in technology. And then also that we wanted it to be ready when the technology was realizable. Historically, VITA's tended to lag a little bit of the commercial industries, and we want to try and facilitate quicker adoption moving forward. If we look at a historical, so VME, that was standardized within VITA back in '95. 15 years later, OpenVPX was standardized, and now we're at the precipice of VITA 100 15 years later. So there is about a 15-year cycle that we're following. Now, this happened just because it's not like we said, hey, 15 years is coming up, we need to do VITA 100. It's naturally driven by the marketplace. Now, another thing I wanted to look at was an industry standard that was a bit ubiquitous. It's not niche. It's pretty much across commercial, industrial, and military applications. So I got the idea from this chart looking at the Ethernet Alliance. And they'd shown this was about 10 years ago. So I've tried to do an extrapolation here, and I'll show you the justification. So this shows the Ethernet speeds, at least those that have been used within VITA. I'm starting from fast Ethernet up to the current 400 gig that was just released this past year. Now, what the Ethernet Alliance did was, while you were to plot this linearly, it would look like an exponential growth. But when you put it on a log scale, you can see that we're starting to taper off. And you can see if you integrate the area under here, that with an increase in speed over the years, there's a percentage increase. So it started with 115% initially, went to 78, now it dropped to 21. And you can see it really started to drag in that crossover from 10 to 100. And one of the things that they had to do, just due to limitations of the technologies and how fast the transistors could switch on the drivers, is they've split it into by 4, what we call in VITA fat pipes. So from there it went to 100, 400 recently. And so trying to do that, I tried to make my interpretation of an extrapolation. I did look at the task forces that IEEE had, and they haven't announced this yet, and tried to do some reading, some sleuthing. It's somewhere in the next 10 to 20 years, I would suspect, another quadrupling. Now, technology could change, that could drag left or right, but I think that's something reasonable to think about. So let's put an overlay of the VITA standards on top of Ethernet. So starting with the follow-on, the VME with VXS, that brought in 1 gig, then OpenVPX added in 10 gig, 46.30, the advance in the connector. Recently, back in a little before 2020, enabled the 100 gig. Now what VITA 100 is, as we'll talk about, is 400 gig. And you see we're catching up. So Ethernet might be slowing down in how fast they're increasing, but thankfully that gives us some time to catch up. And if we follow this, it's reasonable that for the next generations of Ethernet, we're going to have a standard for when that comes out immediately. So there won't be any lag behind commercial. So next step, how are we building on VPX? So that's a bit of the why. So what are we doing moving on from 100? And so part of this is VITA is heavily engineer based. Everyone that's involved in this tends to be development engineers or engineering managers from that standpoint. And so we know that for a successful design, we need to start with requirements and improve that feasibility. So that was done with a study group. That was kicked off by Mercury in May of 2022 to do a study group. And with that, the first thing we did was we spent about a year, and we came up with what the requirements would need to be for the connector itself, and then followed that, how to do the SI modeling. And because the idea for this, similar to the QMC that presented before us, was that there wasn't a connector company saying, here's a connector we want to standardize. It was us coming from the system top down. We have CONOPS that need to be met. these are the requirements we need to do, and now we need to find a technology if it's capable. And so when we did that comparison, we wanted a fair set of ground rules. In addition, we wanted to make sure that it would serve in the environments that VITA standards have traditionally been deployed. And so we did a prototype test plan. That all culminated last year in June, getting the final proposals from two vendors, Amphenol and TE, whose teams did a tremendous amount of work designing connectors purpose-built for our requirements. That ended the close of the study group and transitioned into VITA 100, where the connector was selected. So now we move into the objective part B. So that's learning from the history of VPX implementations, and we're trying to do that in three ways: enhance the interoperability, advance the embedded capabilities, and complete the qualification prior to public release. So let's dive down to those three a little bit more. So enhancing the interoperability. So part of that is we want to minimize the number of slot profiles. Greg Rocco in a couple of presentations is going into a lot of detail about the profile details. But for this one, it's the idea that with more pins, it just allows us to have fewer variations in the profiles, promoting interoperability. The second thing is we want to maintain some backwards compatibility. So we want to move really far forward, but we want to make sure that there's a path for all these deployed systems that exist already, that they can point upgrade single slots, whether it's a processing slot, a switch slot, without overhauling the entire chassis. So keep the metalwork the same, but just upgrade the backplane into a point solution. So talking about building on VPX, these are profiles that a lot in the room are going to be very familiar with. These are pretty common for 3U. You're going to see it looks pretty similar for VITA 100 as well. Now you'll note that the aspect ratio is a little bit wider because it's twice the number of pins. This doesn't comment to the increase of speeds, but you're going to see there's a lot of similarities. There's additional signaling, there's more signaling, and there's faster signaling, but it's all going to be compatible for a growth trajectory from existing systems. So now let's talk about the embedded capabilities. So for this, we wanted to maximize the bandwidth supported in emerging protocols. When we first kicked this off, 400 gig with IEEE was still just a task force. It just recently was released last year. PCIe Gen 6 similarly is in progress. We wanted to make sure that the connector we were doing was going to be suitable for those and be ready when those came out. The next thing was, as we've all seen in industry, as the processing goes up, so does the power. And so we needed to make sure that there was more available power, because we started to tap out was available in 3U and 6U. And similarly, once you have that power, we're going to need to cool it. So the thermal dissipation capacity needed to be higher as well. And the last piece that we've run into is another form factor. Now, this wasn't taken lightly. There was a lot of concern about further bifurcation of the market space and difficulties with that. But there was a real strong need case that 3U, albeit used extensively, has a limitation in its size, that some of the latest chipsets that are coming out, whether it be Intel or NVIDIA, AMD, they're larger than you can fit in a 3U, but you don't want to go all the way up and pay for a 6U. And so the 4U kind of fell out of that. And so starting with that, you can see that we've added a 4U, which is about 60% larger than a 3U, and then a 6U, conversely, is about 60% larger than a 4U. These are kind of rough dimensions about the usable, routable area on a carrier card within VPX. And so you can see that the 4U fits pretty nicely. We think there's going to be a lot of opportunity for 4U. We think that's going to fit a real nice niche and complement the existing 3U and 6U ecosystems. So power. So the two bars you see on the left are the current 3U and 6U when they're running on 12 volts only, which is the current recommendation in OpenVPX. The two on the right. So again, we're talking about a transition plan where initially VITA 100 will be 12 volt based. So you can see that there's certainly more than a doubling in 3U and close to a doubling in what would be available on 6U. That's a current limitation on the connector. But we're also moving to 48 volts. And what that's going to allow is much greater power. And it's not an idea from VITA again, where carrying that over from the telecom and commercial industries about what they're going as well, because they have the same problem. For the amounts of power that you need to move around, 12 volt buses just aren't usable anymore. So then there's the scaling between the 3U, 4U, and 6U. So these are the profiles I kind of just referred to earlier. You can see as we go to 4U, it's more the same. And so we're trying to design an ecosystem that is very scalable and transferable and modular, all those abilities that you can come up with, we're trying to do from the start. And that's from that top-down systems engineering approach we're applying here. The last one I touched about for that mission statement for VITA 100 is complete qual prior to release. So when VPX was first released back in 2006, it was a standard connector that then when put in some harsh environments, we saw some negative responses, in particular fretting. And so part of that lessons learned from that is from the jump, we want to make sure that VITA 100 is already qualified for the representative environments that we expect it to be deployed in. So if there's no false starts, there's no issues in quality. And so we have that baked into our plan. So third point now, what is VITA 100 going to standardize? It's a lot. So we're referring to this as a suite of standards. This top line here is kind of the systems and electrical. And so you see we have 100.0 and 100.1. They have equivalents of the 65.0 and 65.1 46. So you can kind of see what those backs are. Building from that, we're going to need new mechanicals. Now, this met a lot of debate too, because we talked about expanding on the existing 48 specs and decided it was time for a clean start. Trying to shoehorn the 4U in there was going to be problematic. And we also wanted to have opportunities to improve the thermal performance. So there's going to be a backwards compatible aspect that you can use existing chassis, and we're going to be making improvements at the same time to facilitate cooling with these higher powers. System management, Dan Tui from Mercury is going to be talking about that some today. That's going to be new capabilities from what was done previously. So we're starting a new standard for that. Connectors, Mr. Mike Walmsley from TE will be talking about that for both the copper side and also the coax and optical. Power supply, we talked about one, we have a new 4U form factor, but we also need to bring in 48 volts. That's going to drive a new power supply standard. Signal integrity, new connectors, new speeds. There'll be a new standard for that. And lastly, we're going to work through some test and development standards, RTMs, things of that nature, to really build up the bench. And let's look at what the schedule looks like. So this shows you where we are today. That's that red star there. You can see the study group started a couple of years ago. That really is what set us up for good success here. So this walks through top down all the current intended roadmap standards that we need and which ones are currently in work. So the base standard, the mechanical, and the connectors are all currently in progress. The power supply is a study group. In the next year, you're going to see a bunch more of these are going to start. So the system management under Mercury, more connectors for the coax and opticals. The power supply is going to transition from a study group to the actual formation. And then moving out the next 2 years, a lot of these are going to move into more updates, maintenance, things of that nature, and some more support documents that aren't needed for the initial release. So again, a lot of work happening here right now. These are the sponsors that kicked off 100.0 and 100.1, and I just happened to look this morning. We currently have 130 members, 132 members in 100.0. There's over 50 companies, close to 60 from 10 different countries. So the amount of involvement we have right now is a lot. And so at least going back to the Thomas thing, I think if Sir Topham Hatt was here, we'd be doing well by Sodor. I think we're doing something really useful here for our marketplace. To summarize, at least the top 5 advancements for what VITA 100 is. Like, what are the just top takeaways and why is it different? Number one, speed. So it's going to be 4 times the data rate compared to what you can currently do today. There's twice the number of pins. So you almost have an order of magnitude increase in bandwidth of data flow. We're expecting more than twice the available power. There's going to be a new 4U form factor. And then lastly, the interoperability is intended to be improved. So it's going to be both backwards compatible with far fewer profiles on the markets.